Hello and welcome to our lesson, our seventh grade math lesson, where today we're going to be doing lesson 10-4. We're wrapping up our unit 10 or our topic 10. And today we're going to be going over subtracting algebraic expressions. My voice seems a little raspy today. It's because the Broncos won and are going to the Super Bowl, and I'm very excited. So anyway, let's go ahead and start with our anticipatory set. Now, I was never a big fan as a kid, but I know a lot of my friends were, of Power Rangers. Power Rangers were the thing to do. So I'm going to do my best to sort of draw. I think they got to a certain point and they had a big enemy to take care of, and they had to sort of like combine together. So we'll just say there's the green one and the red one, I guess, can be over here. And they would do some sort of crazy, like, here we go. Oh no, we need to fight the big old monster. I'll put the big old monster over here. It's like let's make him like a tentacly, weird, scary alien, the angry fangs. And yes, there we go. It's like an evil, tentacly evil person. Okay, and so to fight this person, they would go ahead and power up, and they would become this more powerful giant robot thing, right? Anyone who knows probably knows what I'm talking about. And it would sort of be like someone would control the head of the big old robot, and then this person would control the arms. And then they would fight, and probably the Power Rangers would win in the end. But not really having anything to do with what we're talking about today, but the concept is similar to one of the things that we're going to be talking about today. So let's go ahead and move right along from my fantastic drawings up here to our standard for today. And our standard for today is 7.E.1. Now, we actually have probably 7 standards that go along with this, but that's because we're getting a little further into the year, and a lot of our lessons will overlap. So we're going to go ahead and write down 7.E.1, and then we're just going to note the other ones that we're covering. Okay? So 7.E.1 states that we need to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. So that's the main one we're going to be talking about today. And we are going to be talking, obviously, because we're talking about subtracting up here, is that we are going to be subtracting linear expressions. Okay, so today we're going to focus on this standard, but we're going to focus especially on subtracting linear expressions. Now, we do have several other standards. So I'm just going to go ahead and put also, we have 7.NS.1b. We have 7.RP.2, 2C actually. We have 7.NS.2. We have 7.EE.2, and we have 7.RP.2. So there's a lot of standards that this lesson covers, or at least touches on, but our main one is going to be right up here, and we're going to be subtracting linear expressions. Okay, because we know linear expressions and because we know how to subtract, there's no language of the discipline today. So we're going to jump right into our input. And in our input, instead of going through our language of the discipline first, since there's nothing you need to know, you know it all, we're going to go directly into our details. Okay. And then I want you to go ahead and add our rules icon to the top middle here, because we're going to go ahead and come up with some rules. Now, the first thing goes for the whole lesson. This is what we base it on. So go ahead and write this down as well. When you subtract two algebraic expressions, you distribute the minus sign as you remove the parentheses. Okay, so that's our main rule we want to remember. That when you subtract two algebraic expressions, you distribute the minus sign as you remove the parentheses. That's something you don't have to worry about when it comes to adding, but here in subtracting, we're going to have to remember that. Okay, and then I'm going to go ahead and pick two colors, and surprise, surprise, I'm going to go ahead and choose orange and blue. Very exciting. Okay. We have two methods that people like to use when we come to subtracting algebraic expressions. So over here, I'm going to go ahead and write method 1 in blue, and in orange on this side, I'm going to go ahead and write method 2. Okay, and then I'm going to go ahead and use black, and I'm going to mark this down the middle so we have two sides. We can go ahead and look at these two sides. Okay, so we have two methods that we're going to go ahead and look at today. Let's start with method 1. In method 1, you are going to subtract each term inside the parentheses and you're going to remember that the subtraction sign inside the parentheses is the sign of the second term. So in this case, in the example we're going to do, you'll see it when we look at the negative 7x. So in method 1, we are going to subtract each term inside the parentheses. So we're just going to distribute out that negative sign, and we're going to subtract each term. So I'm going to go ahead and put down our example, which is x plus 4 minus 2 minus 7, so 7x, sorry. So you can see that we have two algebraic expressions, and they're being subtracted. So we have x plus 4 and 2 minus 7x, and we are subtracting them. And this equals, this is where we're going to start working on what we're doing. So on this one, we are doing this. The first part is we're going to subtract each term inside the parentheses, meaning we are going to distribute out this subtraction sign to each of our terms, meaning we will start out with x plus 4 minus 2 minus negative 7x. And now that my flimsy little anticipatory set will actually come in handy now. Because remember, one of the rules that we have is if you have two come together, it's going to change to something. So let's pretend up here that these are both negative signs. When they come together, they form a positive sign. So there we go. That's how it fits in. But down here now, we have this. So the next thing we're going to do is we are going to remember that negative and a negative equals a positive. And this will become x plus 4 minus 2, and now we have a negative and a negative, and those two will become a positive, adding 7x. X plus 4 minus 2 plus 7x is now our new equation. Now the next thing we do, now at this point, we should be pretty good. We've done really what we need to do. We now just need to simplify. And the first thing we need to do with that is find the like terms. Find the like terms. Oh, he froze. Okay, hang on a second. We're not going to give up on this, not quite yet. You're going to see me. Hello. All right, very nice. We're going to get this all figured out. This is your little break. Take a breath. Let's think about how awesome the Broncos are. And let's see. Here we go. Fantastic. All right. Hopefully that worked out for everyone. Now we had a little brain break. And let's continue. Okay, so now we need to go ahead and find the like terms. Well, we have x, and x is a variable. That is going to lead us to x plus 4, because we have a positive 4, minus is the sign of that term. So this is a positive x because there's nothing there. This is a positive 4, negative 2, and a positive 7x. Okay, last bit of information, or last step we really need to do is simply to simplify. And we are going to simplify to get a single algebraic expression, which would lead us x plus 7x would give us 8x plus 4 minus 2. 4 minus 2 is 2, meaning 8x plus 2. And that would be our answer when we subtract using method 1. So that's method 1. This is the method I prefer. And we've frozen again, haven't we? That is terrible. Just terrible. So hang in there. Hang in there. We'll get this to work. Don't you even worry. Let's see. Okay. Let's try it this way. Okay. A little less resolution, but hopefully a little bit more focus on it. Okay. That is now method 1. Now we're going to hop over to method 2. Method 1, we turn those into a subtraction problem. Method 2, we are actually going to be changing and rewriting subtraction as addition. So now we're going to rewrite subtraction as addition. So we're going to turn this into an addition problem, is what method 2 is. Now I prefer method 1 because looking at this, more. So let's go ahead and start. We'll use the exact same problem, okay? And the problem is x plus 4, 2 minus 7x. Now, the first thing to do is to figure out what we're going to be doing first. Now, instead of just distributing out the subtraction sign, we are going to rewrite this as addition. So the first thing we are going to do is actually just change this to a positive, meaning we need to do something to account for that, which would be x plus 4. Now we're going to be adding, but we can't just substitute that. So we need to add a negative right there, why I believe this way is a little bit more complicated. This -1 right there helps us do that. It just is a strange step. But then you'll see how this breaks down now. Now, instead of distributing out the minus sign, we are distributing out the -1. So let's go ahead and distribute the -1 to the 2 and the -1 to the minus 7x. This is my orange side. I'm sorry. So that was our distribute. Which now means this equals x plus 4 plus -1 times 2 -7x. Okay, so now you can see in between our two expressions we have that addition sign, which is what method 2 does. We rewrite subtraction as addition. Next thing we do is to simplify what we have. So our next step would be to simplify, which would give us x plus 4 plus -1 times 2 is going to be -2 minus -1 times -7 is miss that because we have the subtraction sign right there. So that was my fault. I'm sorry. See, I like method 1 better. Method 2, craziness. So on this one now it's a -1 times a 7, which gives us minus -7x. Okay, that makes more sense. Then we use our little Power Rangers thing to subtraction give us an addition, which means we rewrite this as x plus 4 plus -2 plus 7x. So those two subtraction signs become the addition sign. Our next step would be so our like terms here are 7x plus 4 minus 2. And if you see this right here, you may realize this looks an awful lot like what we had over here. So now we do our like terms, and now we go to simplify. And you'll see this will give us x plus 7x gives us 8x plus 4 minus 2 is 2, and our answer is the same. Now, you can make your own judgments on which one you would prefer. I much prefer method 1, because if you look, it's the same thing. We are distributing out this negative, which really, that negative right there isn't. Okay, so you have your two methods. Problem. See how we do on that. So I'm going to go ahead and move this page and get a new page. Forward with our modeling. Okay, and our modeling question for today is going to be, I'll be writing it out right here, 2 internet cafes offer plans the first one, which I'm going to call Connect and Joe, offers 35 cents to connect and 5 cents per minute. Now the other one, which I'm going to call, and I like this name better that I came up with, Sip and Surf. I think I could make good money off that. Sip and Surf offers 15 cents $0.04 per minute. What we need to do is write an expression showing how much more costs. Okay, so you will get a question just like that that has some information in it, and you will need to sift through this information. Okay. Is it that we know? We need to find out what it is that we already know. Well, if we look in here, we know that one of the places, which is called Connect and Joe, it's 35 cents to connect and 5 cents a minute. We also know that the second place, which is called Sip and Surf, offers 15 cents to connect and 4 cents per minute. So we really know that. So let's go ahead and write down exactly what we do know. We know the place called Connect and Joe. We know what it costs to connect, 35 cents. We also know the rate. That is 5 cents. And we know what is the variable. The variable is minutes. Okay, we also know that there's a place called Sip and Surf. And we know in the Sip and Surf place, it costs something else to connect. You know how? 15 cents. We know the rate, which is 4 cents. And we know the value is also minutes. Once we have what we know, we can start to think about what we need. So these are the facts we know. What is it now that we need? Well, we need exactly what it says right here. We need more Connect and Joe costs. So we need an expression to represent the higher of Connect and Joe. Okay, this. First of all, we know the place called connect and Joe. Let's go ahead and get that expression first. We know to find that expression, we're going to have the connection plus 5 cents per minute, or per minute on internet. So that's in a word. The connection is what? The connection is 35 cents. So it's going to be 35 M as minute, obviously. I'll also need to find the sip and serve. Well, the sip and serve, we're going to need the same thing, the connection plus 4 cents per minute on internet. And we know those numbers as well. And we just need to make sure that they're in the right order. Well, when we look at it, more Connect and Joe costs. So that's going to go first. So it's going to be Connect and Joe minus sip and serve, which would be 35 plus 5M Now look at that. All that work, but we finally do have our subtracting of algebraic expressions. Now we just go through and do well, what's the first thing we're going to do? I'm going to use method 1 here. You can the subtraction sign here and the subtraction sign here, meaning our new equation will be 35 plus 5M, then minus 15 minus 4M. Next thing we need to do is we need to find those like terms. Well, minutes is the variable in both, so I know that they are like MM, and this are two numbers that do not have variables. Those are like as well. So we're going to have 35 minus 15, 35 minus 15 M minus 4M. And finally, we simplify. Meaning we do 35 minus 15, which gives us 20, and 5 minus 4 plus 5 minus 4, 5 minus 4 is going to be 1M. 20 plus M. So connect and costs 20 plus M more than sip and serve. And that would be our answer. But I know I'm right because I did all that work. Okay, that's going to be it for our modeling today. And we're going to go ahead. I'm going to go ahead and write down what your guided independent practice is. Today, our guided practice is going to hooray, hooray. You do not have any independent practice today. However, you do want to go on and do some your adaptive practice on front row ed because you need to get at least half an hour of that done for the week. Okay? So that's your work for today. Great job. Good luck. And go Broncos.